Welcome to XXIM YouTube channel. In this video, you will meet Michael Sutton, the mastermind behind Kaspa's Crescendo hard fork, a seismic leap that is turbocharging proof of work to 10 blocks per second.
That part needed to be engineered so accurately that I've never been involved in something so delicate.
Ankit sat down with Michael to discuss Crescendo backstories, technology, and all the energy that was poured into the hard fork.
Last but not least, or the most significant person who actually helped me carry Crescendo through was Coderofstuff.
You will learn about Michael's masters and his love for distributed computing.
Taking theory and being able to apply it and actually show it working in the world, that's my sweet spot. Always think from the eyes of the adversary, and he's very mighty. He can do a lot.
You will learn about Michael's vision for decentralization, along with a brief overview on draft future roadmap from DagKnight and atomic composability.
There's a few nuances. I wouldn't call it fully based. I'll be focused on orchestrating and finalizing the paper along the way. That's what me and Jonathan. That's more or less how I see DagKnight.
If you believe in Kaspa, then you cannot afford to miss this video.
I remember people asking me, Michael, is this actually going to work? Or are we trying to do the impossible?
Hi, welcome to XXIM Podcast, your home of decentralization. Today, I'm here with none other than Michael Sutton. Welcome, Michael.
Hi.
Thank you so much for your time. I'm really looking forward to our discussion today. I wanted to have you here to discuss not the future, but the past with Crescendo update. I wanted to be, really focused on Crescendo, more on the personal side, but also on the technical side. So let me start by asking the first question, which is, it's been 2 months. Crescendo actually went live on the 5th of May. How are you reflecting on it now?
I'm still watching it in awe, maybe. People could see it at the live video we shared. It was very interesting to see it folding, happening. I took my time in terms of relaxing, doing a lot of research already, just observing for now.
Because it took a while, right, to actually launch Crescendo, from the time you were doing testnets for a year. I think we were told by IGRA guys, I think they mentioned it was running on a testnet for a year.
Yeah, so we had testnet 11, the 10 BPS testnet running since January 24.
Right, so it was 14 months.
It was running smoothly, but there were performance issues. We decided we need to optimize some parts so that we lower the threshold for mainnet. We don't want it to be too demanding, so we took the time. But the testnet, the fact that the testnet was live and wasn't down, it was just straight up live all the time, was a significant boost to our confidence.
Yeah, I think exactly. For me, Crescendo definitely changed the world for me. When we can see 10 BPS blocks per second happening on a proof of work chain, that's just mind-boggling, right? It's a new paradigm for me, and I really want to get into the backstories of perhaps things people are not aware of on a personal level. But before that, though, Michael, I want to sort of understand your background. So you did MSc, Masters in Computer Science from Hebrew University, and then you thing I know is you ended up contributing to Kaspa. So please take us through your journey from doing Masters to Kaspa.
Yeah, so my Masters wasn't on distributed systems consensus research. You'll soon realize how it is connected to what Rusty to Crescendo. But so my master's was around what you'd call system research, high performance computing, specifically high performance computing. My first paper was about a multi GPU system. You have this node with 8 GPUs with very fast communication, local. You can have a single CPU process controlling several GPUs. And what happens if you try to run a task or an algorithm to use all this computing power? So it's pretty easy to solve when you have like a structured problem, like a matrix multiplication,
Right.
maybe. So you can distribute like the data and obviously non-trivial, but still predictable. My focus was on unpredictable algorithms, like specifically graph algorithms, where the problem is irregular. So you don't really know ahead of time how to distribute the load. So it was about optimizing the usage of this hardware
Right.
beast.
So
it was about high performance, no adversaries.
did you say unpredictable algorithms? That was the focus for you. Right.
Yeah, they're like unstructured. Problems where the algorithm itself discovers where the computational load is. So you kind of need to dynamically adjust to the data.
It sounds a little bit like DagKnight, the direction DagKnight wants to go in.
The dynamicness, but it's completely different realm. It's the stronger connection is graph. The fact that most graph algorithms are of that nature, because a graph has varying structure. I can give a short sentence on what a graph in computer science is.
Please tell us what a graph in computer science is. Yeah, please.
A graph in computer science is the abstraction of a set of vertices and an edges between them. So it's a very powerful abstraction. It's a very well-defined mathematical structure, which you can map to many real-world problems. Like you can model Twitter as a directed graph, right? Like a follower-followee relation, or any social network can be modeled as a graph. A roadmap can be modeled as a graph, where each intersection is a vertex. It's just a powerful abstraction, and so many graph problems are unstructured by nature because the graph data can have abnormalities. And then the BlockDAG is also a graph.
Of course,
So my thesis and my master's was all about like high performance computing. It was never about like a model where you have an adversary. It's all about cooperative tasks where you have like a bunch of computers, a bunch of GPUs trying to solve one problem together. So you have a single point of management where you can manage the flow if you need to. There's no there's no notion of adversary. That's like the main. So it's so it's about the theory of parallel computing and the practice of high performance coding.
Right. No notion of adversary. That's cool.
Yeah, it's the classic where you have like a supercomputer and you want to run an n-body simulation or something a huge physics simulation over a supercomputer. So you have all the resources. No one is an adversary. So you just need to optimize the overall. You need to minimize communication so you have the collective power solving the problem in the fastest time possible.
So you sort of did your master's. Then how did you ended up in Kaspa?
So a lot of my research in master's was driven by experimental research more than theoretical research. And you can actually have brilliant papers which their main result is real world benchmarks and performance data where you don't necessarily need to prove you optimized or you proved theoretically. There's a realm where you can show real world how you actually solve the problem faster based on benchmarks. Like in graphs, you have several benchmarks. There's all kinds of graph structures. So you try and pick like a good set, multiple sets which each represent some different data pattern and show your solution is general enough to solve many kinds of data patterns. Specifically, I wasn't touching enough on theory, and I wanted to do more theoretical research towards my PhD. I was thinking about doing a PhD.
Right.
We can get back to that.
Yeah. Right. I was going to say, on the theoretical side, right? Jonathan, I think, and Shai were in the same class, I believe. I think Shai mentioned one of the sessions we had with him.
They were the TAs of the same class.
Yeah, Shai mentioned. Yeah.
Yeah.
Yeah, I see.
Yeah.
So you're more on the practical side. I think they were more focused on the theoretical side.
Yeah. Also, yeah, I did, like, I think they did their PhDs when I did my master's. I wasn't like running into them too much at the university. Hardly so. I only met Jonathan eventually at one specific course, and we didn't even speak. He just saw he knew what my name is. And then at some point, he came up to me at the cafeteria or something.
Right.
And said something about a startup he's starting. Yeah. So just to finish the line of thought. So I was wanting to shift to theory. And then the opportunity came to do an internship, a summer internship with Jonathan and DAG Labs, where I can start researching things related to cryptocurrencies, which was a completely different world for me, but not too far away. It's still distributed systems. Okay, there's an adversary.
There's
an
adversary. Yeah, I was going to bring. I was saying there's plenty of adversaries. Plenty of adversaries, right?
It's a big shift in your mind. You have to always think from the eyes of the adversary, and he's like very mighty. He can do a lot. Like, give him all this power, so you don't assume too weak models. So you actually give him so much power, and then you have to prove that this power is insufficient. And that's the second, like, that's the most exciting element for me in distributed systems. Byzantine distributed systems. When I say the word Byzantine, that's exactly the adversary part. Byzantine represents like the case where there's a Byzantine attacker. So what happens is, like, you take a paper like DagKnight and you prove it completely theoretical. You prove a completely combinatoric theoretical proof, and you study, and it's hard because you have to actually prove that there's no way an attacker can use. You have to prove an impossibility. You have to prove there's no attack vector. So even though you can't really cover all the attack space, so you have to find creative ways to prove such a thing. But then you can take this theoretical proof and use it and build a practical system relying on that proof. So that shift and combination of taking theory and being able to apply it and actually show it working in the world, that's my sweet spot.
I think it's the 51% Byzantine attack. It's such a the crucial component of cryptocurrencies, let's put it this way. So you ended up at Kaspa through this internship, basically. So that opportunity came up, and then you are now talking to DAG Labs about this internship.
Yeah, so we're talking April, maybe March, February 2019, starting to talk. Then I joined in April that year.
2020? This would have been 20.
Yeah, we 2019. And we're April 2019, and we're discussing a summer internship, kind of research project.
Project.
Yeah, it's actually the first internship, the first project I looked into, because it was like so. I suppose Jonathan was thinking, because we have a scoped few months. The challenge was to start designing the L2 over Kaspa. Over Kaspa wasn't yet the name yet, and there was no. But that he actually wanted to vision how could smart contracts be built on top of this already then, and that's our main research topic now. So that's
you come full circle, yeah.
Yeah, but then back then, zero knowledge technology wasn't mature.
Sure.
So we looked into other, more like fraud-proof systems.
Yeah,
you know,
like optimism and stuff. They have some fraud proofs, right?
Yeah.
So now you're at Kaspa. Were you excited by it that time? Kaspa in name wasn't even there at that time. But were you excited by the vision, at least, of sort of taking and expanding proof of work to be this new blockchain that's going to come up with a new name? Were you excited by it? It was more of more just internship came up. Let's see where it goes.
I was first, to be honest, I was excited about the aesthetics of Jonathan's research.
Of course you were.
I read.
I see.
I read Spectre in the GhostDAG Phantom paper back then, the version that was online back then, and I enjoyed the aesthetics, the thinking, the modeling, the theory. I think that's part that attracted me the most.
Right.
I also, doing that research, I read for the first time Bitcoin.pdf,
Right.
Satoshi's paper. I think I had the aha moment. Again, it's more about the aesthetics, just enjoying the fact that you putting together the reward system for incentivizing miners and getting the security from the computing power they contribute. So that tick, that was like, and I think all the details were known prior to Satoshi. I think that connection was his main contribution, actually. So, so connecting game theory in a sense with consensus, and also the slight shift from general, before Satoshi, consensus was all about deterministic finality, and then became this probabilistic creature. Interestingly, my thesis is related to random graphs and random graph analysis. So that also seemed interesting. Then I started that internship project. Then it didn't end and it just continued. Eventually, I got the research question from Jonathan about, which led to DagKnight.
I want to come to DagKnight because I'm sure you get all the time all these questions post Crescendo, when DagKnight, when you're going to publish some content. So we'll park that till later.
Yeah, I have a draft.
You have a draft post. I will ask you at the end when you're going to be publishing it. So it's a suspense element for everyone now. So cool. So now you're at DAG Labs at that time. Let's call it Kaspa, right? It became Kaspa later on. So now coming back to Crescendo, I think part of the discussion I wanted to have with you is really the sort of backstories on the personal level, right? And really focus on some of the things that perhaps not many people are aware of. And one of the things I wanted to ask you is, who were the sort of, you're obviously the mastermind behind it, right? Who were the other co-contributors that perhaps were involved in Crescendo?
Yeah, that's a good question. I think there are two parts to answer here. First of all, the whole rewrite of Rusty Kaspa in a high performance way was aiming for a faster BPS system. Otherwise, the current system, the Go system, was fine enough. Was okay with running 1 BPS. So obviously, every contributor to Rusty Kaspa, starting from summer of 22.
Summer of 22. So that is 2 years.
Yeah, I would say we started summer 22 and we got the 10 BPS system, Testnet, a year and a half later.
Right. So,
then the following year was mostly about stability, just being careful with such a high stake financial system, doing it slowly, gradually, testing, because it's a big change. So that was just taking things serious. But most of the development happened in that year and a half. So I'm just saying that every contributor there's like some contributors to Rusty Kaspa were only like Elichai was only active at the first half of the year, because he essentially wrote the cryptographic layer of Rusty Kaspa, like the hash functions, the mining function, whatever stuff, the cryptographic parts. So and he optimized like he always does, and he was a Rust expert way before me. So I'm saying every line of optimization is the seed, is part of the seeds to Crescendo. So that's anyone contributing in that first year and a half has a significant part in what became eventually Crescendo. But then there are the people who actually carried this into mainnet, because it's one thing to have a testnet running 10 BPS from the start, and it's another thing shifting the gears live on a mainnet without downtime, and all the final optimizations also that were done throughout 24. So there are, that's where I can name mostly Ori Newman, Maxim, and last but not least, or the most significant person who actually helped me carry Crescendo through was Coderofstuff. He put his shoulder down and to carry, I told him I need you with the same responsibility. I don't need your help only.
See.
I thought before we declared any timeline for Crescendo, which we did, I actually got him to say, I'm in it with you. We're carrying this together.
I see.
Oli and Maxim and others were very crucial also for reviewing, and specifically Oli and Maxim took on a lot of parts related to the script engine, which we can get back to, as you mentioned, Keep 10.
So I hear Maxim, Coderofstuff, and then Oli, I think sorry, I'm not sure.
Oli Newman is another DAG Labs. He's one of the original developers of Kaspa. I think I'd say he wrote maybe not most of the Go code base, but the most significant parts of the Go code base. And he also really helped with rewriting a lot of the code. Yeah. So he's been there throughout, and also towards the end. He's always there when we need him.
Cool. I was going to say, I think, this is so important for me, and I think perhaps for the community to really understand and listen directly from the builders, from the people that are behind the scene, right? They sometimes come out on Twitter, but I think we want to highlight them in our podcast. So I'm really actually quite happy and pleased that you're actually mentioning that. That's why I'm trying to perhaps get more names if they were involved.
Yeah. And the full list of Rusty Kaspa contributors is much long.
How many contributors will be there if you look at core contributors to just contributors? We spoke to Izio Dev yesterday, actually, day before yesterday, and he is also a contributor, tiny bit, he said, on Rusty Kaspa.
So I'd say there are 10 people, or approximately 10 people who made significant contributions. Like there's one guy, his Discord name is Hauntedcook. He's been around. He wrote the first GPU miner for Kaspa, open source Rust GPU miner. Like his GPU miner was used for several months by most of the community before the more professional GPU miners came out, especially after the ETH merge. So his miner was the one used for like months. He wrote he wasn't involved in the code base, mostly not involved in discussions, but he took like 10 months or something, and he wrote the script end, which is a very isolated component. And the fact he did it was really was a relief for me. It was like one big task that's off my table. So I'm just giving him as an example of the kind of we had that kind of people doing their thing, their phase.
But you still have to do the PR, right?
After review, you have to review. Reviewing is underrated.
Yeah, exactly. I was going to say review is as perhaps takes as long as actually. I mean, not as long, but it takes a long time. Yeah.
I think the most significant, like what I can say to upcoming people who want to contribute, always make sure that your pull request is as easy as possible to digest. Like if it's overwhelming for me, so I can't use 1 hour I have here and there to look at it. I need to get a day. But if it's separated into components, it's much easier for me to fit into a schedule and just do it more casually.
No, totally. And cool. No, I think it's amazing to at least get these names out and to broader community to see. And just on the timeline, so from the ideation to launch of Crescendo, it was summer of 2022 to actual deployed mainnet was May 5th this year, right? So you're really looking at over 26 months, something like that.
More like two and a half years.
True. Yeah, 2.5 years.
So I like I told you before, I think after half that time, more or less, like a year and a few months, most of the effort was done. Yeah, actually, the consensus engine was done in a few months. It was like I think I wasn't online at all. I was just doing a lot of coding.
Any specific stories from that time of setbacks or things you wanted to launch and the KIPs you wanted to launch in this Crescendo hard fork?
The dust attack and the solution we had to come up with, known as Keep 9 or storage mess.
I see. Yeah.
That also came along around this time. There was a heavy research, mathematical research done. Proof of this formula is like a 6-page mathematical proof.
Right.
Yeah. Not out in the world yet. So this was an effort done like the first half of 24, I think. So the final list of KIP we had into Crescendo, it wasn't planned like so much in advance. We went as we go. we just spontaneously realized that we had to deal with setbacks and with various things, and we had to make sure that storage requirements are bounded and are well known. So we had to develop like moving to 10 BPS was like taking everything to the extreme. So we had to really be careful about what's going on.
Yeah. So that sort of leads me to the keeps itself, right? So in this instance, you're talking about keep 9. And, you know, I was just going through the documentation, perhaps. There were, 5 keeps that were integrated or part of Crescendo, right? Keep 4, keep 9, keep 10, keep 13, keep 15? Or were there anything I missed?
Yeah, 4, 9,
13,
10,
15.
13, 15, and 14 itself contains, 14 itself is like the hard fork one.
Yeah.
References all the others, but it also has a few inline changes. 14 is like summarizing them all into one package and saying, let's put this into Crescendo.
Right, I see. So 14 is a summary of all.
Like 14 has the fact that we allow payloads. That's in 14.
We allow payloads.
So, and that's
significant. That is huge now for all the builders that are constantly talking about payloads here.
Everything you see now, Cassia is using payloads, obviously. Payloads simplify KRC20. I don't know if they already implemented the simplification, but KRC20 had to do like a workaround in order to inject general data into the transaction.
Right. And also for this layer 2's coming up, right? So that sort of relies on payload as well.
No other way. Yeah, obviously it's like the main usage.
Yeah, exactly. Yeah. I think I see what you mean, right? So it's both ways, right? It's mutual. Because layer 2s will have to sort of constantly looking for that, right? The payload.
Yeah, they mostly follow the payloads that target them.
They target them
by some specific rule, by prefix or something. It's like L1 actually acting as the sequencer and the data availability layer. But without the zero knowledge part, there's no settlement. You cannot it's one-way communication in a sense. Like the L2 observes and gives its interpretation to the payloads, but L1 has no idea what this interpretation is, what it means on any state, and it cannot be proven to because there's no zero knowledge verification yet on L1. So
that's the based rollup that you just defined there.
It's the based without the
settlement. Yeah. The settlement part is separate. Yeah.
Settlement is critical because for canonical bridge, for having CAS flow back and forth in a trustless way, you need zero knowledge. So but you have the based. There's a few nuances. I wouldn't call it fully based because there's no real commitment.
There is no fully commitment from the layer 2s.
Yeah, it's the social commitment. The social agreement is to follow the L1 sequencing, but they're not committed to it. And through an L1 mechanism.
Yes. I hear you and I understand.
I mentioned it on X. It's I think maybe you were on the.
Yes, I was actually. We had that a while back, maybe a couple of weeks.
Like if the main point was that if you have this very extreme event and someone is trying to force you to roll back. Yeah. So in the case of with no zero knowledge, you only need to force the L2 community to roll back their interpretation and ignore some transaction maybe. And they know L1 is not a part of this, will not be a part of this, no one will need to consult L1.
Yeah, I was trying to think.
And when there's a zero knowledge program you're committed to, you can't just change the rules.
Yeah, you have to rely on the layer 1 for verification. I was going to say this happened in one of the chains, right? That started the debate where I can't remember which chain was it, where they were able to roll back on layer 2s, right? On a stable coin.
It was brought up like after a discussion about like the Bybit
I
hack.
think so. It was one of the hacks.
It just brought up
where they rolled back.
Brought up many discussions related to what's the meaning of code is law.
Code is law. Yeah, ZK proofs or zero knowledge does that, but not before that. I see. So if we jump quickly onto the keeps itself, Michael, if we just quickly go through perhaps some of them, right? So 9 and 13, if I bundle them together, right? So they were mostly linked to the storage that you guys had to deal with, right?
Yeah, so two kinds of storage, like the long-term persistent storage, which is essentially the UTXO set.
So this on the keep 9, right? That's the part you had to resolve on keep 9.
That's the more challenging one. And then keep 13 is just being more explicit about the size and the block size limit, because we have this mass definition, which also takes into account like computational costs, like signature verification has like increases the mass by 1,000. And we wanted a unit to be focused on only the size, like how much does it cost to keep this transaction in the database in disk for a few days. So that's why we created also the transient storage mass, and we modeled it as like few dimensions. They don't like, there's a few different limits. So I'd say keep 13 is important, but not like it just made sure we know exactly to calculate how much 3 days of data, how much disk you need in the worst case, without influencing other parts. And but keep 9 is much more significant because it solves a much harder problem.
Yeah, I was going through it, so it sort of avoids because of the 10 blocks per second, it avoids the state bloating for UTXO set, right?
Kind of regulates how the UTXO set grows over time. The challenge is applying a local cost function to each transaction, such that the global dynamics have a bound. That's like the magic part,
right?
And not hurting UX of users, of normal users. So how do you distinguish an attacker with an honest user? You don't necessarily distinguish, but you can identify patterns. And in that sense, keep 10 is also related to keep 9. Like keep 10 became more general, introducing what we call introspection of codes to the script engine and covenant, and by that having some kind of covenants. But one of the main motivations for keep 10 was actually what we call additive addresses, which was part of the solution of keep 9, what keep 9 was trying to solve. It was saying, okay, keep 9 is adding this cost function, but what happens if there's a honest user who still wants to do a micro transaction, which might seem like dust? And so how do we counter that?
I see. Could you please explain the dust attack, please, for perhaps people that are not aware of it?
Pretty simple. If there was no limit on the like a UTXO entry and UTXO set is composed of UTXO entries.
Bunch of entries,
key, and the entry is mostly the public key controlling that Kaspa, the amount of Kaspa, and the DAA score of representing the time, whatever. So originally the amount could be as small as you desire, up to some limit, but it can be really small.
The Kaspa or
one out of the Kaspa amount in the UTXO entry can be very small, conceptually. So the Kaspa supply is fixed by 28 something billion, but each Kaspa unit is actually composed of 100 million zombies or dwarks or vitas or whatever you call them. So what if I try to, if I create a UTXO entry, if I take like 1 Kaspa or 100 Kaspa and break it into the smallest units, I'm actually going to increase the database size for everyone. I can create 100 million entries, dust entries for with 1 Kaspa, for instance. Okay, so that's taking it a bit too much because, we had a limit of not allowing like a single zombie, but only like 1,000 zombies. Okay. But it's still a lot. So what happened is someone actually, there's a lot of block space not used, not always used. So he actually took a small amount of Kaspa, I think a few dozens, and he broke them into the smallest unit, the mempool allowance. So he created a transaction with 1 input and like 80 outputs. And he filled blocks.
Oh boy, I see.
And I think the database grew like in a few hours by a few gigabytes.
That is crazy. So that's the fix for it, basically.
Yeah, so there was a fast patch that was like applied on the mempool level, but keep 9 was then applied also on the mempool level as a more long-term solution. And at Crescendo, it was activated at consensus level. So now we're no longer depending on the goodwill of miners, but actually the system is actually secure. So even if a miner like collaborates with some attacker, he cannot. Yeah, he has the same limitations. So essentially, the rule of KEEP9 is trying to identify this pattern of creating dust entries.
I see.
So it's not always so easy to spot because you would. Yeah, I don't know if we should drill on this.
I think it's interesting, right? Because how would you differentiate it from a normal transaction to an attack? That's actually valid. Next question I was going to ask you. Maybe high level you can discuss.
You would think maybe the rule of thumb can be any transaction which has more outputs than inputs is actually increasing the database size, right? That would be like a very problem is the most basic usage pattern of a transaction is like taking one UTXO I have, sending someone part of the amount and sending the change back to myself. So the most common usage pattern of users is 1 to 2. It's very common to see a 1 to 2 transaction. And if you say, okay, let's allow 1 to 2 and disallow 1 to 3, then you're not fixing anything. 1 to 2 is already exponential growth. You can already, that dust attacker used 1 to 80, but he could have done the same with 1 to 2, just a little bit slower. But it would still be like an exponential growth. We realized you have to look at the output distribution. It's not about how many output entries, it's about how they're distributed. A dust attack will always have to create smaller and smaller output values. So if we penalize the cost of an output and reverse to its value, we can try and capture the pattern. Yeah, that's more or less suggested.
Yeah, no, that's cool. That's cool. No, thank you. I think that was beautiful. Just quickly on the KIP 15, which was I think was I think it was Dennis who put it. It was Mike Zach, I think he mentioned that it was a one-line code.
Yeah, it was a few lines, but it is significant for the base rollups pre-ZK. Essentially, that line was mentioned also in the zero knowledge research posts we have. Like part of the design was it was called in history root in the first post. Then it became a sequencing commitment. It's the same idea. You want to be able you want L2 to be able to commit to a sequence defined by L1. So you need these anchoring points in L1 to help the L2 prove that he's following the correct sequencing easily. You need succinct anchoring points. You need like something that's easily passable to a zero knowledge prover as a public argument. I don't know if you know enough about public args, there's private witnesses.
I don't know that part, no.
But then also you wanted prior to ZK to be able to prove the L2 wants to prove to. I think the most common usage is proving to new L2 nodes who want to sync.
Yes.
So the L2 is going to show them all the transactions aimed at the L2, and he wants to prove them to them, assuming they have access to their own L1 node. They want to be able to verify the sequence of transactions applied to L2 in the most efficient way. So that's the fact that we have sequencing commitments is really, I'd say it's if you look at it from as a theoretician, it's only like a constant improvement, but it can be a large constant X. It can reduce the storage costs. I don't know, a few X
for a tons, right? The new nodes that are getting created for lectures.
Yeah. It also helps creating a pretty small witness. If you don't need an Atan, only need to the best illustration for what KEEP 15 gives you is that I'd say if you need to keep a receipt of accepted transaction in the far past, you only need approximately 2 megabytes in the worst case now for proving a transaction was accepted by Kaspa anytime. So that's also part of what KEEP 15 gives you. So
and also the pruning time was reduced, right?
Yeah, it was reduced. Not tenfold.
No.
It was reduced from 50 hours to 30 hours. It's actually, because it happens every 12 hours, so you actually keep data for between 30 and 42 hours, because it's not so you accumulate 42 hours and then you cut the first 12, so you
I
get
see.
to 30.
Right. Yeah, it wasn't tenfolds. Yeah, it would have been nice for for node operators.
It's a good question. Yeah, it's possible, but it has there's trade-offs. Let's say it's too technical for now. To get into.
Yeah, no, fair enough. I think perhaps for another session. But anything outside of these 5 KIPs we discussed, and KIP 14, which was a summary of everything. Anything that perhaps we haven't touched upon specific to Crescendo?
Technically, that by definition, all the changes are there. So yeah, technically, Crescendo was an engineering challenge. Besides the consensus changes, I'd say the most significant challenge maybe was the real-time peer-to-peer traffic.
Real-time peer-to-peer traffic.
Yeah, what happened? When the DAG is forming alive, so the exchange of blocks tightly and with minimizing the delay as much as possible, so the structure is connected. That part is probably the most, like, that part needed to be engineered so accurately that I've never been involved in something so delicate. Like, the correct lines of code here and there made the difference between a system which is always converging correctly and a system where some nodes just fly out or fall into infinite loops of catching up and stuff like that. So being tight and accurate was, and the main point I'd say, why was it significant moving from 1 BPS to 10 BPS? Because the RTT time between 2 nodes, far away nodes in the network, can be 200 milliseconds or 300 milliseconds, and block time being 100 milliseconds makes it all much more significant, because there's more. That's the threshold we passed to the downside, which made everything challenging, but also especially, I'd say, the peer-to-peer real-time exchange.
I see.
So that's so that's not like a consensus rule. It's obviously affected by consensus, but that's a piece of that was the main difference between we launched Testnet 11. There was once before the time I mentioned, and we realized we wrote everything we had to fix. I think that was like the main thing that had to. It was also slightly unknown. Like, I remember people asking me, Michael, is this actually going to work?
I bet.
Can this work, or are we trying to do the impossible?
Yeah. I spoke to Paul Wonson from KII, and I think he was holding this like Paul said, he wanted to see himself will get to 10 bucks per second. It was quite funny, actually, because it was a marvel, right, in itself, to get to 10 blocks per second. Never has happened before.
And also, like, pushing the gas pedal one moment. That was
that's the challenge. But so now you're on the other side of this equation. Now it's sort of working, and you're obviously keeping an eye on it. On a personal note, before we get into the little bit of future for this episode, so you took some time off, and obviously, felt good about this massive upgrade that just happened. Yeah.
But I also decided that, personally, that Kaspa's next hard fork will have much more people.
I see.
Carrying the weight. It's just more correct. It's the natural progress. There are going to be much more stakeholders involved, L2s. So it's happening naturally, but also it has to happen just.
On a human level, I think the toll it is any upgrade. I've been part of some upgrades in the past, and especially in the distributed ledgers, I think it's next level, especially. The type of upgrade we just did on Kaspa.
It's hard. It's hard. I think people who are non-technical and non-engineers can appreciate it to some level, but not really.
No. So I think we'll see more, perhaps more people that are involved in the hard forks in the future.
Yeah, that's naturally
It's
going to happen.
with the layer 2s and perhaps more people getting involved.
There were a few people. I'm just saying, what I mean is mostly we need to jump one order of magnitude up. I'd say you want like 10 people involved in the next hard, knowing all the details of the next hard
for
fork.
sure. Yeah. And it's also truly decentralized also, right? We want to have knowledge distributed between different people, right? I think that's also a big part of it.
There's nothing I want more like that.
Yeah.
To emphasize, it's not one person now.
Sure.
It is 3, 5, 6 people. But
But perhaps I think it's more just easy to understand that how important it is to have knowledge distributed.
That's like maybe why I'm trying my part. I'm trying to do my part in this. So besides answering technical questions all the times, if I can, also doing the workshops.
Right. Okay. Yeah. And where can people go to attend these workshops?
I always publish them on X and on Discord, and usually we do it in the Discord meeting channel.
Right.
So, but it's also last workshop was broadcasted live on YouTube by someone, and then the recording was available right away.
Perfect.
But it's significant in the sense that you walk people through the code base, and I draw on I draw like whiteboard drawings and try to make it like kind of a class, but also walking through code and showing how all the theory and everything is implemented. So it's trying to get people at least under some scope into what I know, passing everything I know, so someone can take that and like if there's something to do around that area.
Yeah, awesome. No, I think it's great. If people weren't aware of it, and I'm sure there'll be newcomers coming, so they can obviously join this Discord sort of live sessions when you do them.
They can see there are already like free workshops on YouTube. You can just search like my name and workshop, Kaspa workshop. You'll see.
Cool. Awesome. So Michael, moving on to some big things that are happening now. So I think I perhaps initially mentioned that we'll talk about DagKnight. So why don't we quickly talk about what you're working on now? And you have the upcoming post. You said it's already drafted, but it's not published. So what is coming soon?
The most significant thing I'm working on right now is actually like atomic composability between zero knowledge systems. We can touch on that.
Yeah, I did a session with Igra actually recently on a topic, atomic composability. Very small session, like 20-30 minutes, I think it was. We touched upon the high level, but yeah, please, I'd love to.
I think there's a lot of unknown, so you can't.
Yeah.
There's a lot of research or things to understand. To me, it's still foggy, I'd say. We're still in the phase where the clarity is not, it's about clarifying things now. Eventually, been there before. Eventually things become simple, and I'm pretty sure it's going to happen here too. So regarding DagKnight, I'm more like in the phase of this planning how to do this. I'm not going to give too much spoilers. It's a complicated. It's both. Like there's I think there's a version we can aim to, which is, I call it V0 or DevNet version, which is about taking the current algorithm and simplifying it, taking away all complicated parts or unknown parts, but implementing the basic DagKnight idea and structure so that we can build on that. And that's saying, okay, let's not get stuck. If there's an applied research question, say the paper has an algorithm which there's no obvious efficient implementation for. So let's either skip that or make an inefficient implementation, but not focus on that for this version. So that's how I see it. So it's understanding the basic components of the algorithm, implementing a first version which avoids all complications, and also applying like the broad code base consequences of this change. Mostly it's a change about the ordering protocol, like a specific module. Where you're changing, you're saying let's select the select parent not by BlockDAG but by DagKnight. That's like the main outcome. the ordering protocol we're staying in the realm of chain-based DAG ordering. We're just changing the chain selection rule.
Very simple, of course.
Nothing too
very simple.
Yeah.
Right.
So that box itself is complicated, but it's pretty much, let's say, isolated and self-contained. But there are usages of Ghost DAG, the blue blocks, blue set, the coloring for rewards. There's all kinds of usages out of the ordering protocol itself. And those usages, not necessarily, DagKnight doesn't necessarily provide the same kind of semantics. So you have to, so that's a part we know how to do, but it's part of the initial effort. So it's kind of, you're placing this box inside the code base, but then there's a few usages you have to make up for.
Right.
So that, I'd say, that's how I see. And then there's an effort to the second phase of the effort is about clarifying all the things you skipped at the initial phase. So implementing one of the algorithms which is challenging in the best efficient way, etc. But there's also an effort to simplify the protocol and make sure the proof isn't broken, like it doesn't break. I think the current protocol is complicated. It has a few complexities which were introduced in order to streamline the proof. But time has passed since, and we grew up a bit, and we have a few new ideas, which can also be more sound engineering wise, and can also make the proof simpler and stuff like that. So there's also an effort around that mutual walk of the paper and the code, which I'd say is the second phase. I'm aiming for a system where we can have others code, and I'll be focused on orchestrating and finalizing the paper along the way. That's what me and Jonathan will do that part. That's more or less how I see DagKnight.
So did you say a paper? So it'll be a new paper on DagKnight coming out? Because there is already a paper, right?
A new version maybe. There's actually a lot of internal versions since the last public version, where we actually framed a lot of, even I'd say, the narrative of the paper a bit differently.
I see.
So it's not, so eventually those versions are gonna consolidate, and we're gonna publish them also. There's just too much to do.
I bet when you're, I guess, operating at that high level, you just always have something to do, and perhaps too much to do, as you said.
Yeah. Now I'm trying to, I mean, there's always times where you have to stress, you cannot pull through Crescendo without a few sleepless nights. Okay.
Deployment has to be done that way, right?
But you have to have the times where you're more, even though there's a trillion things on your mind, you're doing them one by one. I maybe a post-season NBA, I don't know.
You're training your
divide the year to more calm, training.
Getting ready for that next season.
Yeah. So obviously it's always doing a lot, but just not stressing it, because it's
and
just
you're
hard.
very active on X also. I've noticed, and you are always responding to people, which is, I'm sure.
I try. I don't answer everything. I guess what happens is that if I get a question which I feel like I might be able to answer, but if I have to stay online it's obviously going to lead to discussion. So I might just stay out of it because I can't pay the price. If the question is framed in a way where I can just write the answer and that should be enough, that's what I answer mostly.
Do you think we can use Grok 4 for some of that?
For what? For writing the answers? You're touching on something interesting. We are exploring paths for using AI systematically for addressing the challenge of core being busy, everyone involved in building being busy, while you still need to communicate. So there's AI can definitely help, and
100%.
there is an effort. It's not only about just plugging in Grok, obviously, but yeah, there's an effort.
I'm joking, but I think that's definitely the direction a lot of comms will go.
No, we have an engineering effort around this.
Yeah. Cool. Michael, I have this fun little segment we created. We ask everyone now, where do you see Kaspa in by 2030? 2030. So we are in 2020.
2030, we should have technology-wise, we should have everything I know of at this point.
So zero knowledge of codes on layer 1. We have smart contracts on layer 1 running. Is it Sparkle or native smart contracts? You think?
Not exactly native in the sense that we're going to execute smart contract logic by all L1 validators. That's a path we're going to try to avoid for avoiding centralization of L1. But the experience of an app, a zero knowledge app deployed on L1 as seemingly as possible, that's what that's the DevX and UX we have in mind long term for Kaspa.
Right.
Deploying a zero knowledge app.
I created another question for myself. So deploying a zero knowledge app directly on layer 1. In a sense,
yeah. That should be like the experience. You shouldn't be too the developer shouldn't be too concerned about the infrastructure. He has to when you deploy a zero knowledge app, you have to choose an infrastructure, a specific zero knowledge VM, approver network, maybe. So you have to make some technical choices, but your experience in terms of communicating with other apps, that's where atomic composability becomes so significant. Should be a flat experience. It should be like streets, stores on the streets, and not malls.
Right. So we don't need bridges, unlimited bridges that will get created eventually when we have a lot of layer 2s.
So you want it to be so that the mechanics can be complicated, but you have to make sure that the systems are flat, meaning one dimension, in a sense, because you want competition between apps, but apps always want to communicate with others and not self-closing themselves. Whereas infrastructures can tend to want to have everyone under their roof, and so you want to so the game theory dynamics of liquidation and fragmentation and all that, you want them to be flat. So the point is to have a flat system where that's the intuition. I'd say.
So I mean, I can't even start to imagine the scripting language for UTXO and the number of changes you'll have to make to get there.
Yeah, I actually want to pass a point related to this. It's significant to understand that a shared sequencing system, the fact that we're talking about all rollups being based, it means we're still solving one consensus.
Yeah.
Right? If you take Ethereum and rollups, they're not the same consensus instance. Each rollup can be committed to a different set of transactions. There's no global consensus, actually. So by us sticking to based rollups and favoring them because of the throughput we have, and that kind of mindset, by the way, is only enabled by 10 BPS, because if you think about 1 BPS, 300 transactions, you can't imagine it's not powerful enough. Once you see 10 BPS, 3,000 transactions per second, you can imagine how, I recently saw statistics, the whole Ethereum ecosystem is 2,000 TPS at most. When we're talking 3,000 TPS, we're talking sufficient data availability for a lot of usages. And keeping this under a shared sequencer, Kaspa's L1, is very significant, especially if you attach sync composability, because if a transaction can, first of all, you can do sync composability only because you have shared sequencing. Because when you're executing this transaction, the state of all parties involved is actually deterministic. So that's why it makes sense. And when you have sync composability with shared sequencing, you actually have a single consensus system. And the magic part is that ZK can allow you to run away a bit from the replicated state machine design where you have to, each consensus participant has to hold all the state. Zero knowledge is a breakthrough in the sense that it can allow not replicating all data by all machines. That's why I'm saying we're solving. It's not just the words sync composability. It's not just it's redefining consensus in a sense, or redefining how to sequence with zero knowledge. And it's a big challenge.
And I think the security and that layer one will provide along with everything else, along with the sequencing.
Yeah, and without being burdened by itself.
Because excuse me, verification part will be layer one, but the proof part will be I don't even know how actually will go. It wouldn't be layer two. It will be just the DApp itself will do the.
It will be proven networks, actually, either external or internal. Like it can be prover services, like SP1 has now, XXIM Labs.
Tyco has it. I think proven network as well, I believe.
I don't know them well enough, but yeah, I know about Boundless and XXIM, which are like general purpose proving. They have general purpose like proving services. It's like the era of zero knowledge mining, they call it.
I see. Oh boy, there's so much to do and so much to, I'm sure it keeps you up at night sometimes, these thoughts and these topics, and they are at the cutting edge of technology, I think, I want to highlight that.
So I just wanted to say 2030 is, there's more that Jonathan mentioned somewhere on X a few months ago that he's working on something else. So I think I know more or less what he's talking about. He's not. Well, I don't. It's not my job to share too much about it. But yeah, I hope by 2030 we can be deep into that.
Yeah. I mean, any speculation you want to do on technology front.
Technology wise, we should be at the top 3. If we're not, I mean. You can argue we're already there in some sense, but if you speak about the DeFi world, we're still in the planning stage of that, so I can't claim to be there yet. But I hope we'll have a significant role in that world too. Yeah, excited, privileged to be at this point, like humble to be at this point where I can affect something, such a movement. Like watching X recently is amazing. It's just more and more people showing up, more and more clever, well-articulated, people who know what they're saying, what they're doing, people who know the limits of their understanding, acting and communicating about Kaspa. It's very special to watch. Seeing how people appreciate knowledge. I'm not sure how many times in history it's not so often that you see general people who are not necessarily technical, so appreciative of knowledge, of pure knowledge, of science, of applied research, of research. To me, it's special to be in this position of also researching and also applying this. I appreciate it. I think we're going to do well.
Yeah. Awesome.
Market appreciation is important because it creates a whole cycle of enabling innovation. It's obviously something that needs to happen. Hopefully it will happen more and more.